I have drawn a magnesium atom using the typical GCSE model. So I've got 12 electrons to assign. I've put 2 electrons in the first shell, then I've moved to the second shell and put 8 electrons, then I've moved to the third shell and put a further 2 electrons. If I were to draw this in terms of energy, I'm just going to draw myself a little graph with energy on the y-axis. The first shell represents the shell that is lowest in energy. That's why the first shell fills first. So if I were to basically open out those shells and just draw them as a straight line, in that first shell, I have got 2 electrons. The second shell is further from the nucleus. It represents a higher energy level. And within that shell, I have got 8 electrons. And when my second shell is full, I move up to a third shell, which is higher in energy. And into that, I put another 2 electrons. If I am to draw a similar diagram using the A-level orbital model, this first shell, which I had at GCSE, instead of referring it as the first shell, I'm now going to refer to it as the 1s orbital. The 1 because it's the first shell, or the lowest shell in terms of energy. The s because the orbital is spherical in shape. And I've seen that this 1s orbital, like all orbitals, can hold 2 electrons. I'm going to put those 2 electrons in. So far my A-level model is quite similar to my GCSE model in terms of what it's going to look like. I then move into the equivalent of my second shell, and I've seen that at the equivalent of my second shell, at A-level, I have a 2s orbital. That 2s orbital can also hold 2 electrons. And then in the previous video, I mentioned a 3s orbital, which would be equivalent to the third shell, which I'm going to draw up here. And that 3s orbital can also hold 2 electrons. Okay, but at the moment, when I look at my GCSE model and my A-level model, I will see that at GCSE, my second shell is holding 8 electrons in total, whereas at A-level, I've got a 2s orbital that can hold 2 electrons, but I've got nowhere at this point to put my other 6 electrons before I move the whole way up to my 3s orbital. At A-level, at the second energy level, you don't just have 1 orbital, you actually have 4. Okay, remember each orbital can only hold 2 electrons, and if you need to fit in 8 electrons in total, then you will need 4 orbitals. One of those orbitals is spherical in shape, so I call it a 2s orbital, but the other 3 orbitals have a different shape, and we refer to them as p orbitals. There are 3 p orbitals. There's a 2px, a 2py, and a 2pz orbital. As they are orbitals, they can each hold 2 electrons. You will see that even though I've put a 2 in front of all of them to represent that they are all part of the second energy level, that I have drawn the p orbitals slightly higher than the 2s orbital. This is not something we saw at GCSE. At GCSE, the electrons in our second shell were all equivalent. But at A-level, we will see that the 8 second shell electrons are not equivalent. You've got 2 electrons in the 2s orbital, which are slightly lower in energy than the 6 electrons that will fill the 2px, the 2py, and the 2pz orbitals. The electrons in the p orbitals are equivalent. Those p orbitals are all the same in terms of energy. And each of them will hold 2 electrons, which means I now have my 8 electrons for my second energy level, which is what I had at GCSE. I've now got 2 and 8 is 10 electrons filled in. I can then move up to my 3s orbital, where I will put my remaining 2 electrons, just like I had at GCSE. If I were to draw something bigger than magnesium, if I were to draw chlorine, at GCSE, chlorine, which has 17 electrons. At GCSE, I would have put 2 of those electrons into the first shell. I would have put 8 of those electrons into the second shell. And into my third shell, I would have put 7 electrons. When I'm drawing the diagram for chlorine at A level, I'm going to start by filling electrons into my 1s orbital. Again, it's S because it's spherical in shape and it can hold 2 electrons, just like we had with the first shell. I'm then going to move into my second energy level. In my second energy level, I have got a 2s orbital, but I've also got 3 2p orbitals. Each orbital can hold 2 electrons. So in total, I've got 2, 4, 6, 8 electrons in my second energy level, just like I did at GCSE. The difference is that the 2p electrons are slightly higher in energy than the 2s. Then I jump up to my third energy level. In the diagram for magnesium, I drew in my 3s orbital, which could hold 2 electrons, and that's all I needed for magnesium. But for chlorine, you can see that I need to put another 5 electrons in there. Just like the second energy level was split into 2s and 2p, the third shell is split into 3s and 3p. So as well as having my 3s, I have also got a 3px, a 3py, and a 3pz, which are collectively just known as the 3p orbitals. Again, they can each hold 2 electrons. 1, 2, 3, 4, and then I've got 5 to give me 1, 2, 3, 4, 5, 6, 7 electrons in the outer shell of chlorine. Now, when I talked about the s orbitals, I said they were called s because they were spherical in shape. Just to give you a little bit more information about these p orbitals, the p orbitals have a kind of a dumbbell shape, and they kind of look almost as if you've got 2 balloons that are just tied together. Okay, so this is the general shape of a p orbital, and the electron can exist anywhere in these shaded regions. So anywhere in these shaded regions, that electron is just going to constantly be moving around within the shaded region. The px, py, and pz just refers to the orientation of the p orbital. So it can be orientated upright, it can be orientated laterally, or it can be orientated diagonally. But whichever way it is orientated, they are all equivalent in terms of energy. And each orbital is capable of holding 2 electrons. Those electrons can be anywhere within the orbital. Okay, so this is what a p orbital looks like. It's got this kind of dumbbell shape. There's 3 different varieties of the p orbital, just depending on which way it is oriented. As well as the p orbital, you can also have a d orbital and an f orbital. For the bigger elements, you're going to need more orbitals. So you do not need to know the shape of the d orbitals. You do not need to know the shape of the f orbitals. All you need to know that orbitals can only hold 2 electrons. So if you've got a d orbital, it will only hold 2 electrons. An f orbital will only hold 2 electrons. But as you move your way down through the periodic table, and you're getting bigger and bigger elements, you're going to need more and more orbitals. So each time you're moving up an energy level, you're going to pick up another set of orbitals. In the next video, I'm going to go through how you are going to fill electrons into your orbitals, what order you should fill electrons into your orbitals, and we're going to practice writing out electron configuration at A level. So at GCSE, it was just a simple 2H2 for magnesium. At A level, I'm going to show you how you will draw your or write your electron configuration.